All right, this is section 2.1. We're going to be talking about functions and graphs. The homework assignment for 2.1 is 1 through 16 in the homework packet. Start off with a little bit of vocabulary. The set of input values is called the domain. Those are the x values. The set of output values, that's called the range, and those are also called the y values. All right, so let's suppose we have a relation. It's in this particular case, it's a set of ordered pairs. Remember, an ordered pair, the order matters. This number is not doesn't mean the same thing as the second number. If the number comes first in that set of parentheses, that's the x value. The number that comes second is the y value. You should have heard this before. So what we're going to do is state the domain and the range. So the domain, those are the x values, and in this particular relation, it's going to be the set. The braces mean set. -1, 0. You do not have to repeat the 0, and 1. Is it okay if you write 0 twice? Yes. Is it necessary? No. The range, those are the y values. Again, we have a set, so we're going to have the braces. 2, 4, -3, and -3 again, so I don't have to write the -3 twice. Domain and range. A function is a special type of relation. The input has exactly one output. That's easier to understand if you see an example or two. So the directions say find the domain and the range, and then determine whether the relation is a function. So the domain is the x values. So we have -2, 0, 4, and 7. Now let's take a look at those x values. Let's kind of sneak ahead and look at whether or not it's a function. If my x values repeat, then it is not a function. Now, in this particular example, in example 1, I have no repeating x values, so yes, it is a function. With a function, no repeating x values. And the range, -6, 4, 1, and -2. They can be put in order. They don't have to be put in order. It doesn't matter with a set. I'm going to have you do this example on your own. There's another way to tell whether or not a function or a relation is a function, and that's called the vertical line test. If you have a graph, instead of checking the x values, it's easier to do what we call the vertical line test. And the vertical line test says we can draw a vertical line, that's up and down, anywhere on the graph and only touch the graph not at all or once. Well, as you can see with this example right here, here's my graph. If I draw a vertical line here, I touch the graph twice, once there and once there. So this particular example is not a function because it fails the vertical line test. This example, I can draw a vertical line anywhere on the graph and only touch the graph once. Only touch the graph once. Okay, so this one is a function. It does pass the vertical line test. Example 3, find the domain and the range. Also figure out whether the relation is a function. So we'll actually do that first. If we draw a vertical line, are we going to touch more than once? No, that means it is a function. So it is a function. Let's look at the domain and range. Now you have to be careful here because it's not quite as easy as when the points are listed out. So you can't see with the picture, but this actually has arrows on the end. The computer just didn't draw them. So what that means is this keeps on going and going and going and going and going. And since it is a parabola, it keeps on going outward. Okay? So when I am wondering about the domain, notice my graph keeps going out. My graph keeps going out, keeps on going. Well, I do that very badly, but it keeps on going outward. That was my main point. Since my domain is the x values, that's left and right, and my graph keeps on going out to the left, we call that negative infinity. Since my graph keeps on going out to the right, we call that positive infinity. So in interval notation now, the domain would be negative infinity to positive infinity. Let's take a look at the range. The range is the y values. The y values are up and down. So I want to know how far, so we always start with the lowest number, smallest number. I want to know how far down this graph will go. Where will it stop on the way down? Actually, it doesn't. It has arrows. That means keep on going. If I keep on going forever and ever down, that's negative infinity. So now the question is, where does it stop on the way up? Okay. Well, again, I don't know whether I did something wrong or whether the computer did something wrong, but that was actually supposed to go up this far. And we're trying to figure out what the tallest number is on the graph. I'm talking about the graph. I'm not talking about the x and y coordinates. I'm not talking about up here. I'm talking about this point right there. So, what is the highest value for y? What is the largest y value that I have for my graph? And that's 1. I'm going to use a bracket. Remember, when you're doing the domain and the range, if it's an actual number, 99 times out of 100, you're going to get a bracket. There are some rare circumstances where you don't. Infinity always gets parentheses. Example 4 and example 5. So let's take a look at example 4. Domain, those are the x values. So how far to the left does my graph go? And this is the point that's farthest to the left, and that's an x value of negative 1. And like I said, if it's a number, almost always it gets brackets. This is the point that's farthest to the right, and that is at x equals 7. So my domain is going to be negative 1 to 7. My range is up and down. My lowest point is right there, which has a y value of 2. And my highest point is going to be right there, which has a y value of 4. Is it a function, yes or no? Well, no, because I can touch the graph twice, not a function. This one's almost a trick question, but as long as you know how to do it, it's not that difficult. Domain and range. The domain is the x values. Do we have any graph over here? No. Do we have any graph over here? No. This is the graph right there. And the only x value we have on that graph is negative 2. So the only x value for our domain is negative 2. It's not even interval. It's not even an interval. The only x value we have is negative 2. Well, let's look at the range. Range is up and down. How far down does this graph go? Well, the lowest we go on the graph is negative infinity, and the highest we go is positive infinity. It has arrows. It keeps on going. Now the question is it a function, yes or no? Well, can we draw a vertical line and only hit one point? Always? Well, if I draw my vertical line over here, I'm fine. If I draw my vertical line here, I'm fine. What happens if I draw my vertical line here? How many times am I hitting that graph? Well, a lot. So, does this pass the vertical line test? No. Function notation. If I have a f and parentheses and then x, this is not a case where parentheses means multiply. This is a case where it's specific notation. This is the name of the function, and this is the variable that I'm going to use in my function. I read it f of x. So let's suppose I have a function f of x is equal to 2x plus 1, and I want to evaluate for f of 4. What that means is my x value is going to be 4. So I'm going to take 4 and I'm going to plug it into my function for x. I'm going to replace my x value with 4 and figure out what that is. 2 times 4 is 8, plus 1 gives you 9. So we say f of 4 is equal to 9. Now the 4 is the x value. The 9 is the y value. So this is actually a point. My x value is 4, my y value is 9. Anytime we say f of x, you can replace that with y. All right, example 6. Find f of 5. So I'm going to take 5 and I'm going to plug it into my graph, or plug it into my equation, I mean. Negative 1/9, multiply it times 5. If you recall from fractions, both of them need to be fractions, so I'm going to put a 1 on the bottom. And when you multiply fractions, you multiply the top, you multiply the bottom. So 1 times 5 is 5, 9 times 1 is 9. Example 7, f of negative 3. I'm going to, anytime I have an x, I'm going to replace it with negative 3. Remember, when you substitute in, always substitute in with parentheses. Always, 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 always substitute in with parentheses. And it's important to realize that I have parentheses here with the exponent on the outside. What that means is negative 3 times negative 3. Negative 3 times negative 3 is a positive 9. Now I have a negative and a negative. That becomes positive, positive. When you're subtracting a negative, it means add a positive. So add 3 plus 1. Oh, hold on. I messed up here. Sorry. I got carried away. Let's try it one more time. I forgot to replace my x with negative 3. Alright, sorry about that. Negative 3 times negative 3 is a positive 9 plus 1. Multiply the 4 and the 9, you get 36. And finally add, and you get 46. All right, I'll do example 9. You guys are going to do example 10 and 11 on your own. So, remember, this is the x value, and the whole thing is the y value. So I'm going to look for an x value of negative 1. Where is the x negative 1? Well, here is where my x is equal to negative 1, right there. My question is, what is the y value when the x is equal to negative 1? Well, I have a point right there. So what I'm looking for is the y value. 1, 2, 3. My y value is 4 when my x value is negative 1. word problem, the amount of water in a leaky bucket is given by the linear function f of t is equal to 120 minus 10t, where f of t is in ounces, t is in minutes. That tells you, if I'm trying to find after 2 minutes, that tells you this number has to be t. T is in minutes, this is minutes, then this number has to be a t value. So my t value is 2. 120 subtract 10, my t value is 2. 120 subtract 20 is equal to 100. Now it says f of t is in ounces, so 100 ounces in the bucket. All right.